You probably think of the sun as a bright shining light that never changes. In reality, it's an unbelievably huge ball of molten gases that's constantly in flux. From time to time, it ejects fiery packages of matter and radiation, events known as solar storms, which can wreak havoc on our planet. The largest recorded solar storm to hit us was in 1859, known as the Carrington event. It was so powerful that it caused chaos for the telegraph system. It gave telegraph operators electric shocks, and some telegraph poles sparked and caught fire. It also caused aurora to span almost the entire world, with the southern lights being reported as far north as Queensland. Some experts predict that a solar storm on this scale should hit our planet roughly once every 150 years. So being over 150 years since the Carrington event, we can't help but wonder, what are solar storms and what kind of damage could they cause today? Our dynamic exploding sun. The sun is an active star, far away and behind the cover of its blinding light. The dynamic nature of the sun's surface can easily go unnoticed. But astronomers have been aware of sunspots for thousands of years, with some of the earliest reports by Chinese astronomers describing them as bursting fires eating a chunk of the sun. Sunspots can be tens of thousands of kilometers wide, and they grow, shrink, move, and disappear over time. They are also one of the most easily observed indicators of the sun's tumultuous activity. When there are many sunspots, the sun tends to unleash more violent space weather. When there are few sunspots, we are generally safer. What exactly are sunspots? According to NASA, the sun, much like Earth, is going through its own kinds of activities. However, since it's the star of our solar system, activities on it have a massive impact on all the planets, including Earth. Despite being mostly hydrogen, 91.2% of its atoms, the sun isn't a simple ball of gas. It's made of plasma, and that plasma acts in different complex ways depending on whether it's at the core, the outer corona, or somewhere in between. As plasma moves around inside the sun, it generates magnetic fields that extend far into space. Scientists do not yet fully understand the complex physics of the sun's magnetic field, but we do know that when strong fields around sunspots interact with each other, solar material can be ejected into space, sometimes with the energy equivalent of 1 billion of hydrogen bombs. There are two main kinds of violent magnetic explosions that occur above the surface of the sun: solar flares and coronal mass ejections. They can, but don't always, occur at the same time, and they produce different effects. Solar flares. Solar storms start with a huge explosion on the sun. These explosions of light and energized particles, called solar flares, can be about as powerful as billions of nuclear bombs. When seen with a solar filter on a telescope, they can appear as a flash of bright light. Yes, even brighter than the sun's usual blinding light. If they occur in the line of sight from Earth, rather than on other side of the sun, they will affect the space weather around us in just little as 8 minutes. Scientists who study solar storms have discovered that the frequency of solar flares appears to follow an 11-year solar cycle. Coronal mass ejections. Coronal mass ejections, also called CMEs, are clouds of plasma and magnetic fields hurled into space. At their extremes, they can contain hundreds of billions of kilograms of charged particles, traveling at a speed of several million miles per hour. These clouds and the shock waves they cause can take up to 3 days to reach Earth if ejected towards us. But unlike solar flares, not every CME seen from Earth will affect the environment around our planet. When looking at images of the sun, flares appear as bright flashes, and CMEs are seen as ejections of matter. What follows these explosions are storms around Earth, but not our usual kinds of storms. Solar storms are unlike the strong rain, wind, and lightning events we usually think of as storms. Instead, they come to Earth in two main forms: radiation storms and geomagnetic storms. Both manifest in different ways, so let's take a closer look. Solar radiation storms. Earth is regularly bombarded by radiation from the sun. Our magnetosphere stops most of it from reaching the surface of our planet, but during a solar flare, the sun spells out solar energetic particles. These particles penetrate the magnetosphere, creating a solar radiation storm around our planet. Luckily, our atmosphere absorbs those fast-moving particles that make it through the magnetosphere, so we don't need to worry about the radiation risk, assuming we are on the surface of our planet. If you are an astronaut, particularly if you are far away from Earth, you may be outside the protective zones of atmosphere and magnetosphere. This means there is an increased radiation exposure risk for astronauts after a solar flare, and passengers and crew in high-flying aircraft at polar latitudes may be at increased risk too. For those of us elsewhere, even the most extreme solar radiation storms won't affect us biologically. But if we are unprepared, we will almost certainly notice their effects on our technology. Solar energetic particles can interfere with radio communications and damage electronic circuits. Again, however, these charged particles don't tend to make it to the surface of our planet, but satellites in high latitudes or located far from Earth's surface can be at risk. If satellites cannot be moved to safer locations or shut down to a safe power mode, solar radiation storm may render them useless. Losing satellite and communication system is more than just an inconvenience for our lives and our economy. It can have real life and death consequences, like when trying to land an aircraft safely. Geomagnetic storms. Geomagnetic storms are major disturbances of Earth's magnetosphere, the space surrounding our planet governed by our magnetic field. The storms can be observed as beautiful aurora in our night sky, but they can also cause major disturbances in Earth's power grids and navigation systems. Have you ever seen an aurora? If so, you have probably witnessed the result of a geomagnetic storm, the largest of which are caused by CMEs. Aurora are produced by energetic particles in Earth's magnetosphere, caused by an exchange of energy between the solar wind and the space environment around Earth. The solar wind and solar magnetic field does spark the Earth's magnetic field during a geomagnetic storm. The resulting interaction energizes particles circulating within the magnetosphere. These particles travel down magnetic field lines where they collide with gases in the atmosphere, producing the colors we see in the skies. Geomagnetic storms are more than just beautiful. They cause increases in electric currents flowing in our magnetosphere and our atmosphere. If power systems are left running during extreme geomagnetic storms, transformers can be destroyed. If local, national and international power systems are interconnected, the damage can cascade. And if hundreds of transformers are destroyed at once, the time needed to replace the equipment could lead to blackouts that last long beyond the duration of a storm. Other potential effects of geomagnetic storms include disruption to radio communication, reduced accuracy of satellite navigation systems, malfunctions of electric systems, and possible confusion among the diverse range of animals who use Earth's magnetic field for navigation. In 2012, the Sun emitted a huge CME, one that could have been even stronger than the Carrington event. Fortunately, Earth was elsewhere in its orbit as the plasma ripped through space. If the storm had erupted about a week earlier, it would have hit Earth, and the estimated cost of the damage that would have ensued is around 20 times that of Hurricane Katrina. Whereas the impact of a strong solar field on Earth could be disastrous, but it also saves us from interstellar events. The magnetic field in solar wind help us to protect the solar system from high energy particles from deep space, including the remnant radiation of supernova explosions, cosmic rays, and gamma rays. Changes in the solar wind also have various effects on the space around Earth and contribute to the dynamic environment we call our home. So while the solar wind is always blowing and it's an essential part of our cosmic environment, it can deliver big changes to planets over time or with a big enough gust of energy.